9, number 20. So it says, which of the following is an expression for f of x? These are based off of our Maclaurin expansion for the ones that we need to memorize, like sine, cosine, and e to the x. If we look at this pattern here, we see consecutive numbers 2, 3, 4, and we know it can't be sine. We know it can't be cosine, because if it were, then our values should be odd or evens. So this kind of reminds us of e to the x. The degrees are a little bit off, but at least the consecutive nature of it is consistent with e to the x. So this is what e to the x looks like. 1 plus x squared over 2 plus x cubed over 3 factorial. If I want to get the numerator to match what I want with degree, I want to increase all my degrees by 2. I basically can think of it as I'm going to multiply everything through by x squared. So let's say I have e to the x, multiply everything through with x squared, and then I have something that resembles what I'm trying to go after. However, there's some additional stuff, right? What do we not want from this x squared e to the x? Right, we don't want the x squared, and we don't want what? X cubed. So what if we just subtracted those out? So this is basically my x squared e to the x without my x squared and x cubed. So I can just basically say x squared e to the x, but I don't want the x squared and x cubed, and that will end up removing those and allow me to start at the first term that they want us to start at. Good, everybody okay? The other question that I saw, I think page 17, number 90. We're trying to match the Maclaurin series here. So this is our general rule for our Maclaurin series. Everything centered at 0. But the definition that they give us is not the general term. It is a general term, but it's a general term for just the nth derivative at 0. So they're only giving us the general term for these spaces. So after we find our f of 0, f prime of 0, f double prime of 0, f third derivative value of 0, after we find all those values, we still have to include the x and the 2 factorial and the 3 factorial. And that's how we're able to get to our answer there. So f of 0 is 1/2. So 1/2 gets plugged in for that. F prime of 0 is negative 1/3. Negative 1/3 gets plugged in for f prime of 0. F double prime of 0 is 3/16. So that gets plugged in for that. But then we still have to divide that by 2 factorial. The rule is only giving us a portion of the series. And then the fourth derivative of 0 is negative 1/10. So that goes in that space, and then that cleans up to what we see there.
So for like n 0 equals 1/2, would you plug in for n? That just
that would be 0.
okay. And then everything follows.
Yeah, everything follows. N1 will be first derivative, N2 would be second derivative.
Okay.
Yeah. Yes.
I had a question on number 87 on page 16.
Okay, 87, page 16.
I just wanted to know, like, how did you find the values for x and c? Like, I think I mixed it.
Okay, so this problem says that we're centered about x equals 0. So anytime you see the word about, that they're describing for you what the center is. So in this case, center is 0, which means that the other number is going to be your x value. And if they give you an interval, one will be the x, the other will be the c.
It always in that order.
Not necessarily, but they will give you context clues to tell you what this where the center is.
I think you just plug in one for each of those. Because what if the max value of sin of x equals 1?
Yes, but all we need to know is to find the maximum value on this interval. So sine of 1 is not the same thing as sine of x equals 1. So because of the calculator question, we can do this. We can just plug 0 and 1 into our fourth derivative and see which one produces the larger maximum value. And e to the sine first is larger than e to the sine of 0. So we're going to keep that in that numerator space to give us the best value we want.
Basically, do that every time you plug in the inputs.
Yes, unless it's a problem where, let's say if it was just sine of x, between some random interval, then this is always going to max out at 1. But the fact that there's e involved, there's just a little bit more unknown there, so we do want to test it. But yeah, usually if it's a sine and cosine, I know, okay, if it's just that, I know the max is just going to be 1. So on this topic, I do want to just make sure that that we can gain some clarity between alternating series error bound and LaGrange error bound. I mean, it's great if they announce which one it is, but sometimes they don't, and I want to make sure that that we are clear on that. So this is the handout, just kind of going over those distinct differences, or how to tell the difference between those two, especially if they don't tell you explicitly that it's AST or LaGrange error bound. So the alternating series error bound states that so let's start off with alternating series error bound. States that for a converging alternating series, the error approximating its sum using a partial sum is less than or equal to the absolute value of the first unused term, the next term in the series. And if you ever see this notation, absolute value of R sub n is less than or equal to A sub n plus 1. Oh, sorry. The error bound is given by this. Yeah. So we know that whatever polynomial that we're sitting at, we know that the first unused term, the next term is going to provide us a good ballpark value of the accuracy of our approximation. It doesn't mean that it's the exact approximate exact error, but it's a good ballpark value, especially something that we can find really quickly. So, however, be aware that the first unused term may not be the next consecutive degree. It's whatever the rule of sequence gives you. Okay, so whatever the next term is, whatever the rule of sequence gives you, that's going to be the term you're going to use. Depends on the rule. Sometimes the rule can skip every alternating degree. So it's just whatever the first unused term of the sequence gives you. For example, if you want to find the approximate accuracy of a partial sum S of 3, then the absolute value of the fourth term of the sequence is the error bound. Okay, so let's say we're given this series here. You can tell that this is a alternating series that converges because there's an alternator here. So whenever you see this notation like this, absolute value with two different functions, this is asking you for the error. Okay? It's basically saying, what is the maximum difference between the actual function's value at 1 versus the polynomial version of at 1? Okay, so whenever you see this notation, just know that they're trying to get us to use error bound. So we're going to show that the error bound is less than or equal to 1 over 4,000. So let's build out our first few terms. So to build out the first few terms, follow what the rule of sequence tells you. The rule of sequence is asking you to build it out starting at 0. So plug 0 in for n. Anything to the 0 power is 1. The x stays. 2 times 0 plus 1 is 1. So I'm just left with x. X is my first term. Second term is at n equals 1. Plug 1 in for n. That's going to give me a negative 1. So minus x. But if I plug 1 in for n, 2 plus 1 is 3. And 3 factorial is the result of my denominator. Next term is 2. Plug in n equals 2. Plug 2 in for n. I get a positive because negative 1 to the second power is positive. X will stay there. And then if I plug 2 in, 2 times 2 is 4. 4 plus 1 is 5. 5 factorial. So now if I stop here, this is my third, my p sub 3. Right? This is my p sub 3 of x because I have 3 terms here. So therefore, my p sub 3 of 1 is going to be 1 minus 1 over 3 factorial plus 1 over 5 factorial. Obviously, this is not the same thing as f of 1, right? F of 1 would include x over 7 factorial, right? It would continue go on to infinity. So we know that this is not going to be the exact value as p of 1. So the question is, can we have a ballpark value of what the accuracy of this p sub 3 at 1? And if I want to find the accuracy of this p sub 3 of 1, I can just look at what? My fourth term, right? So I know that f of 1 minus p sub 3 of 1 is guaranteed to be less than or equal to the absolute value of my fourth term. And my fourth term is by plugging n equals 3 because I'm starting at 0. So my fourth term will be, this is n equals 0, n equals 1, n equals 2, n equals 3. So if I plug 3 in for n, I get negative 1 x over 7 factorial. I plug 1 in, I put the absolute value. So 1 over 7 factorial is the maximum error of the accuracy of this approximation. And 1 over 7 factorial is 1 over 5040, and 1 over 5040 is clearly less than 1 over 4,000. So we've achieved our goal. We've shown that our maximum error is clearly less than 1 over 4,000. So I see some students feel like, oh, the next unused term, it must be involved 6 because that's the next value over. It's in this case 7 because that's what the rule sequence tells us, right? So whatever the next term is, that will tell you the error of your polynomial. So signs of alternating series error bounds. There is a mention of alternating series that converges. Most error-bound problems on AP exams are alternating series error bound. LaGrange error bound appears less frequently. So a lot of times you may go through the entire AP exam and not see LaGrange error bound. But if that's the case, then you're guaranteed to see alternating series error bound. One of those two will show up. It's possible both shows up, but you're guaranteed to have at least one show up, and the chances are it's greater that your AST error bound is going to be the one that shows up. First 3 terms. Yeah. Absolute value notations involving difference of 2 functional values indicate error bound. So whenever you see these notations, just know that, okay, they're trying to get you to do error bound some way, somehow. Okay. So if they don't mention alternating series error bound, you can gather that information by the fact that you see an alternating series and you see a converging series. Okay, next page. LaGrange error bound. LaGrange error bound is the maximum possible difference between the actual function value and the value obtained using Taylor polynomial approximation within a specific interval, also known as Taylor remainder theorem. It's great if the problem just tells you that this is LaGrange error bound, but we've been practicing with the error bound. We know C is the center of the series. As the center of the series, we know X is the value that they're asking us to evaluate. Max is the n plus first derivative, and n is the degree of the polynomial I stated in the problem. LaGrange error is an appropriate method when finding error bound for a polynomial that is not an alternating series. So if you ever see a series where there's no alternator and they're asking for error bound, then you know it's LaGrange error bound. So here's an example. Let f be a function where the third degree Taylor polynomial for f about x equals 2 is given. You can tell that this Taylor polynomial has no alternator. So if you want to do error bound for this, we got to be using LaGrange error bound. Given that the fourth derivative evaluated at x is less than or equal to 6 for all x in the closed interval, use LaGrange error bound to find the third degree, remainder of the third degree polynomial at x equals 0. So all the information is provided for you to fill in the gaps for your LaGrange error bound. You're given, this one is nice, they give you that maximum value to insert for the fourth derivative. So plug in 6 for that max location. If you see the word about, that's telling you that's the center of the dielectric C value. About x equals 2. Oh, I'm sorry. Yeah, about x equals 2. Yeah, so the center is C. Sorry, yeah, that's right. So about x equals 2, C equals 2, and then asking you to evaluate at x equals 0. So in this case, x equals 0. I guess it really doesn't matter that much because we have the absolute value around as long as we have both values in play. So our max is 6, our n, our current degree is 3, so that's our n value. So we just put everything in and into our formula, and that's going to be maximum error for my third degree Taylor polynomial is going to be less than or equal to 4. So here are some signs that you're dealing with the LaGrange error bound and not alternating series error bound. One, this would be nice if they just specifically reference LaGrange error bound, and that's nice. They're just telling you which one it is. Also, here's another sign. A specific information is given about a derivative value, indicating that they want to provide the student information obtaining the max value. So they give you some random information about the maximum value of a specific derivative. That's the indication that you're dealing with LaGrange error bound, right? They're very specific about telling you, okay, the fifth derivative is less than or equal to 7. So this is an indication that they're trying to get you to do LaGrange error bound. They give you a random information about some random derivative, and usually it's going to be the next derivative that is higher than your current degree. And again, your absolute value, you're going to have a different absolute value showing you that they're trying to get you to use error bounds.
What's the question going to be like? Is it just going to be like, what's the error? Like, is that what that is most likely is error?
Yeah, it'll be yeah. A lot of times it's asking you for what the error is. Yeah, or some variation of the problems that you see in your packet. Yeah, something involving that. Yeah, I think the main thing that I want to make sure that we understand is I saw issues on the test where students were doing LaGrange error bound for AST error bound and AST for LaGrange error bound. So I want to make sure that if you see a problem, that there's enough context clues where you know it's going to be one versus the other. You're not playing a guessing game between those two error bounds. You should have enough information to know either to do the first unused term, or you got to go through this whole process with LaGrange error bound. Okay, I do want us to continue working page 18 through 33. Again, same pattern, first and third problem. I do want to point out a mistake that I said about the AP exam timing. I said 30 minutes for the multiple choice calculator. It's actually 45 minutes. But I think I think some feedback from students that I've had that who've taken this as well as for AB is that you're going to feel like there's too much time, but there's nothing you can do about it. You just have to kind of wait it out. You can't transfer this time into another section. So a lot of students feel like they have too much time here and then not enough time for the FRQs. So just so that you're aware of I mean, it's great if you can use all 45 minutes for these 15 questions, but I think a lot of students are going to be sitting and waiting until the time to pass. Also, you're going to be given, I don't know if I said this yesterday, you'll be given 5 blank sheets of paper to begin with. But if you need more, you can raise your hand. They'll give you more scratch sheet. Okay. Oh yeah, and then also you don't have to bring a pencil because those are no longer any Scantrons. So you should do your FRQ booklet in black or blue ink. It just shows up easier. It's easier for them to scan. So I think it's better if you take the test in black or blue ink.
The exam is going to be AB and then it's exception.
It's all going to be mixed. However, you will have 3 shared problems between AB and BC. And it'll be obvious which one it is on the FRQs. Sorry, on FRQs. But on the multiple choice section, I would say the breakdown is like 65% AB and like 35% BC. You're gonna have more AB content than BC content. Yeah. No, it's gonna be a random assortment. Yeah. In packet 6 that you guys are working through, I put 2 recent or 2 relatively recent years worth of BC exams. I think 2012 and 2014, if I'm not mistaken. So as you guys are working through those, you can see, it's just a random assortment of problems. Oh, and then did I mention yesterday that your graphing calculator section they're not all going to be calculator questions? Okay, so meaning that on the FRQ on multiple choice calculator portion, there's 15 questions, but chances are only like half of them will require a calculator. So don't feel like, oh, how do I get a calculator to do this problem? It's just, you have to make that decision. Not every problem is going to need a calculator. So don't feel like, oh, I got to use a calculator somehow to solve each of these problems. It's just calculator active. You can make the decision if it helps you. If it doesn't, then just solve the problem without it. And then after this weekend, I'm going to see if I can release more of the practice BC exams in AP Central so that you can have, it's obviously not for grade, but I can just give you as much resource as you can as I can. I think there are even more recent BC practice exams, but I think a lot of other teachers, other schools may be using those for assessments, but I'll release them to you after this weekend. Yeah.
So is this the last major grade?
In class, yeah. You still have packets 5 and 6. Sorry. Minor. Those are minor grades. Sorry. Those are quiz grades. But in terms of that's either this is the last test year, right? Last test grade is tomorrow.
Are these 2 separate quiz grades or are they 5?
Separate. They're separate quiz grades.
Separate, and then homework is 50% for each of them, or
For which ones?
The ones that we just, the AB and then tomorrow.
Yeah, all of these are 50% homework.
Okay,
This one is just the clean the packet.
yeah.
Okay, can we do 10 minutes of just starting page 18? Set these equal to each other. It's fine. Sine theta equals, one half, so we fully assume this. Yeah, that's all. Are you blocked out?
Yeah, I'm living in I'm just gonna tell myself something. It's the best place. It's like, at least that. I think that.
So you like.
I think I'm review that. I did like you.
My dad, where's this video? He put me on and I was like, two.
Oh, I think the fine girl is. Yeah, but I don't remember it. It's like the same one, you know, the weekly president. Like, so I'll put her. That's really. Watch me, else tries to guess. Instead of like the line.
We got six.
We got 6. I'll give 5 out tomorrow after your test.
Yeah, because I'm trying to. What's done this week?
Yeah. I can have it ready to pick up now if you want.
All right.
It's 9 and. Right?
10.
Oh,
Is that MCQ? Here's the packet.
like the last on
Want this?
the ACT.
Packet files. Yo, any armies?
It was always for them.
Late stack packet to the hill.
No harm checking.
What is this?
Yeah, you can bring it to.
Oh, it's good. It's good on the high.
I've never taken. Now, Rose has to get. No, they organize it like by different. But it's there, but I don't think they. They should go with five.
So you, who are you getting to play today? No.
The rules are pretty simple, but you have to keep.
It's gonna be the hardest test of the year, so I get like 30 problems.
Yes, basically, you have to win like 3 games in a row
Slash.
to win the whole game. Don't win the games in a row.
He likes.
But whenever you win the square down, which is. Yeah, it
Doesn't
yeah,
like hard stuff.
it, like determines.
My whole table.
Like, where the next player.
It's by association because of X. Like.
Oh, I see. And then PBX.
It's fine. No, I feel. Always find a way.
Wherever.
Double up. They always find a way to have an assessment on the same day.
Alright.
Oh, wait, no. Hold on a second. I'll give myself, give like the UFC second lesson. Wait.
Next week is EOC week and we can sleep in.
I'm good.
Ooh, this is good.
Well, and the lane one is cute. I did that over. the summer. I sleep in for 5 minutes straight.
Yeah.
That means yes.
So you should, yeah, that's what it takes to get to.
I have not been here. Yeah. I might actually. I'm in an AD and take that physics class.
I gotta take like 10 hours.
Unless he's like proctoring, you know.
Like this,
That's so tragic having an EOC program. Sucks for you, buddy. 3 days of EOCs, that's horrible.
Oh, wait, yeah.
Oh, God. I don't think I can pass off the drop gun, unfortunately. No, the ELA EOC is so easy. Like, I got a 99 on this single thing, like summer. You just have to write like a dancing story one of the days, and then like a non-fiction thing the other day.
I'm so curious what a selection class is. Like,
They make it so much harder than I feel this. Yeah, you like make a story.
something about.
I remember I had to write something about like just the house on wheels. Talk about this guy who had a house on wheels. And then the non-fiction one was like, a 200 square foot house in the environment. Yeah, you get an article. The fiction one, you get a story and then you have to write the rest of it.
This one, wait, honestly, it's like.
Yeah. Honestly, not really.
Yeah.
This. Yeah, do you know we got a list of like all the BC topics?
Yeah, page 1 and 2 of your formula sheets. No.
Page 1 and 2. Okay. So did these all the formulas we need to call?
Yeah.
Okay.
Wait, you put it here.
Last question.
Put it.
I took that.
Or we got one. The last question. You mean the effort used? The effort used, not the effort used for the multiple choice, the last two always.
You need to know all these like derivative integral rules.
And not taking myself.
For the AP exam, it should.
They start seeing one.
Everywhere, bro.
There's something.
Yeah, this has, all the derivatives.
And then wait, I need to check this. Because it's that chapter. No.
No,
You're winning.
No.
I can't tell about me.
You're the winningest player. So it can actually.
This you can you just need to be actually terms, but you can profit and
Let's do it. I'm gonna go.
I just, I didn't have to go any further because all the others were zero out. So I just needed to get that would give me. Yeah, I could go further.
No, it has more problems on it.
Yeah.
All right, guys, come get your phones.
Okay, before.
Oh, can you come on?
I'll get it later. I'm best to do this.
Or actually, I want to think about this. If you want to get on that. Yeah, yeah. We're here now, right? Yeah.
When are you
Oh,
The 23rd.
yes, yeah. Yeah, sometimes you can. It's always
They come separate, twist race.
I'm gonna light a news. Oh, damn. Put it here. It's above there.
Yeah, it got becomes nominated. That's like, it feels like.
Obviously, you had
I find that
X1, but
this will require
I'm down
more
here and
cleanup,
I choose.
and they're both for choice. I think
Now,
it's-
it's back up here. Ooh, I like it. I like it.
You can remember, that's the-
Hey, like, leather.
Maybe.
Find the-
Or we could try.
I can't.
I see.
Oh, I'm ready to.
I wouldn't do it.
Oh, no.
I think I'm.
Yeah, I think.
Yeah.
He's already had still great, but.
But we want, so now you get to pick whatever spot you want. Oh, and if it, yeah, once it gets that would be very good.
Yeah. You don't know.
I figured I'd make the game fun.
I did one with again. Yeah. Not that bad. It's a big scale. That's why it's like.
But you have to just like
I didn't know lots of.
react to everything that you say.
I'm like, you should totally do a trial. Here it is. You'll be fine.